AC 111, Lecture 7, Set 3, Traffic Light Finite State Machine. Let's see another example for designing a finite state machine. Here we have an example with a traffic light. We have an intersection of A Avenue and B Boulevard, and we have sensors on these intersections. The sensors, let's call the sensors on this one TA, the other one TB, and each of the sensors is connected to the traffic light on these avenues. Now, what happens is that the system is going to have a clock, and every 5 seconds, let's say every kind of clock tick of this controller system, what is going to do is going to probe these sensors and see what is happening in the sensors. If we have a sensors output are going to be high if the students are present, and if the students are present, then we are going to make this light go to the red state. And these two states actually should be kind of complementary, meaning that not both of them can be green the same time, not both of them can be red the same time. Like, just regular juncture. Now, let's see what happens, in this state. Let's just think about the block diagram. Every time you have, like, a little bit more complex system, let's think about the block diagram. And the block diagram is telling us, we have the system, which is clocked, which says, at which state we are going to sample the sensors. And then, usually on this side, we put the inputs, and then outputs go on this side. So the inputs here are basically, the sensors are kind of input to this electronic system. So here the inputs are TA and TB, and the output is basically what is the state of these lights. Let's call that, light A and light B. So this is basically, the traffic controller that we have in mind. So let's just go ahead and design the finite state machine that corresponds to that. Let's assume that we are starting in a reset state as 0, where TA is basically, no, not TA, sorry. The light A is green, and the light B is red. What happens is that, if this sensor is going to probe itself, and if TA is saying that there are no kind of students, we're going to stay here. If there are students, and then, it's going to say that, this is basically not TA sensor, it's going to go to this state, which we call, say, it's what will happen is that it should go ultimately to the state where light B is green and light A is red. But this is a 3-state signal, so we always have to have this transition. So let's just think that would take one of the clock signals. So let's say this S1, where LA is going to be yellow, and LB is going to be red. But this is a transition state. We know that this is, just going to be only one of the clock signal, according to the assumption. And then we are going to go to this S2, which is, the light A will become red, and the light B will become green. And a similar mechanism goes on here. If we have TB, we are going to stay here. If not TB, what will happen is that we will go to this S3 state, which is the state where LA is red, but LB is yellow. And then this will naturally transition to the next one, as we see here. So let's see how this looks like in System Verilog. again, we have this circuit, this finite state machine, and then we want to design a circuit. And then, if you do this, if you just translate this finite state machine to a state transition graph, we can maybe easier write the code. And here is just the code corresponding to this. Again, we have 4 states, which means that we can explain this with 2 state variable. And then we define that as a parameter, as we've seen before. You could define, the next state and the reset state as a function of this previous state in using the always FF. And then we can do kind of combinational and sequential within one loop. But remember that every time we are assigning to a register a value, we define that as we define this with non-blocking assignment, and else we can use blocking assignment. In this particular case, because the inputs are pretty simple, we just have, the TA and TB, and we are not doing a lot of logic on them. The case statement with the non-blocking statement is used to express everything for the traffic light. Next, we will be talking about the finite state encoding and how that impacts the overhead of the circuit.